Foustenstein's drawing time. Today, we are going to be drawing 4 different types of fronts and how they occur. So it's going to be really important that you guys get these materials for us to be able to draw today. The first thing is that you are going to need 3 different colored utensils. The first one's the easiest. It's a black or dark color. And then you're also going to need something that's going to represent hot and cold. Okay, so make sure you get those 3 different colors. And you're also going to probably need about 4 different pieces of paper so that you can draw the 4 different fronts for us. All right, we'll go ahead and get those materials and then we'll go ahead and get started. Hey guys, I just want to talk very quickly about a couple of the definitions so that we understand what we're talking about here. So first of all, I'm going to be talking about warm air masses and cold air masses. And so an air mass is a large body of air that has the same temperature, same moisture or humidity, and same air pressure. And a front is then where 2 different kinds of air masses meet. And that is a transition area. So if you have one air mass in one location and another one in a different, where they meet is going to be a front. And fronts typically bring that cruddy, yucky kind of weather that we typically think about as far as precipitation, snow, sleet, rain, all of that good stuff. All right, so now we're going to get started on our drawing. Hey everybody, we're going to do our first front right now, which is a cold front. A cold front is our most severe type of front, and it moves in very quickly. I'm going to be drawing for you guys what happens at that front, and then I will be telling you about the weather that occurs after the front moves in. Alright, so the first thing that we're going to draw here is the direction that the air is moving. So if you guys will draw the arrow, and then just write direction of air, just to help us recognize that. Then I'm also going to take my blue and red markers and I'm going to be drawing where the cold air is happening and what is happening with the warm air. So the first thing is that this cold air, because it's called a cold front, this cold air is moving in very quickly. And what happens is there was a warm air mass in that area, and when we draw our warm air on the other side, okay, so here's that cold air moving in, here's the air mass boundary, that warm air is going to rise very quickly, okay, and any moisture that was inside of that warm air is now going to condense and form those large cumulonimbus clouds. It's going to form those huge thunder clouds that we know of. It's going to cause our most severe weather. Now, cold fronts, they move in very quickly, and they also move out very quickly. This is our most severe weather. So our thunderstorms and tornadoes are caused by this, but it moves out quickly as well. And then after the front, we are going to be getting fair weather, but it's going to be cooler temperatures. Okay? All right, be ready for our next front. All right, everybody, here's our second front, and it is going to be called a warm front. So once again, you can title that right there, and then we're going to talk about the direction of the moving air. You guys want to write that in? Now this end, if you could probably guess it, a warm front is where a warm air mass moves in and overtakes a cooler air mass. So I've got my warm, moist air that is moving in, and it's slowly rising above the cooler air mass. So I'm going to put a little dotted lines here. So this is the warm air that's coming in. And then over here is our cold air mass, right? And so as this overtakes it slower, right, because it's warmer and so it's rising up because it's going in this direction, we can anticipate seeing some clouds and rainy weather that will collect, but it will be slower and it won't be as severe as that cold front would be. So it's going to form some clouds, doesn't move as quickly. So it's going to move in slower. You might get some gentle rain at a warm front or precipitation. And then the weather after a warm front moves in is generally going to be warmer, fair weather. But remember, at that front is where we're going to probably be getting those clouds and possibly some gentle precipitation. All right, here we go. Ready for our third front. Hey everybody, our third front is going to be called a stationary front. And if we know what the word stationary means, that means to stay still or not moving. And that's exactly what this kind of front does. So remember in the last two fronts, we had the front moving in a direction. And this time, neither of the air masses are going to be moving. So there's little movement. So at the bottom, you guys can just put little movement of air. Okay, so it's not really moving in any direction, if you can see that. Then you've got a warm air mass and a cool air mass. So I'll draw my cool one too, or cold air mass. So here is cold air on one side, and we've got our warm air on the other side over here, but neither of them is moving too fast. So this one's coming in this direction or not moving very much. This one's moving right here. What you're going to see here at a stationary front is an area of clouds. Okay, you might get, so what could happen is just depending upon the amount of moisture that is in the warm air, this front stays or lasts for the longest amount of time. A cold front doesn't last very long. It moves through very quickly. That's where we get our thunderstorms and our severe weather. A warm front may last about a day or so, but these stationary fronts can actually last. So I'm going to say moves very slowly and may only can last like 3 to 4 days. If there's a lot of moisture in this warm air, it can allow for a lot of precipitation over an extended amount of time. Afterwards, depending upon what air mass kind of overtakes the other one is the kind of weather that you are going to get, but just be ready at a stationary front that it's going to stay still and it will give you cloud cover, and depending upon the amount of moisture, you could get that precipitation for 3 to 4 days. All right, be ready for our last drawing of the day. Hey everybody, our last front that we are going to be talking about is an occluded front. And an occluded front happens when we have two cold air masses that actually push a warm air mass upward. Okay, so the direction of the front or the moving air is going to be in one direction. So the direction of air moving. Now the difference between an occluded front and a cold front is that there are two different kinds of cold air that's coming in. So I've got cold air coming this way. And then I've also got cold air over on this side, over here. And what's happening is there's a warm air that's right in the middle that's rising up. So it's caught in between. This warm air is going to be rising up, and as you can guess, this is going to be giving us, okay, lots of precipitation. Okay, so I'll be putting some raindrops in here, okay, because both of those cold air masses are pushing that warm air to move really high. It can also bring some strong winds and heavy precipitation. It moves in and out fairly quickly, though, not as fast as a cold front would, but you could see some heavy rainfall with an occluded front. All right, stay tuned because I want to show you guys all the different types of fronts on a weather map.